Hello, in this presentation we're going to show you how to create a 6-meter diameter circular hopper out of folded plate and the required supporting structure with all joints and accompanying documentation. So let's start a blank file, and I'm going to start off by doing some simple construction work. So I need an arc to start with. Just put in some simple dimensions, and I can convert that arc into my curved beam. It's going to support the hopper. Okay, I'll have a bit of channel, so actually that seems to have come up with the correct size for me. Get it in the right position and tell it what part it is. Now I'll move that up to the right height instead of ground level, and I'm going to draw one of my columns on the end of that. Again, it seems to have come up with a suitable size for me. I'll tell it that's a column. And I'll adjust the position of that a little bit. Now I don't actually want the column right on the join between the portions of circular ring, so I'm going to rotate the ring 10 degrees like that. Now we need a nice connection between those members. So come to our connection vault, and from the categories we choose the desired joint type and select the members it applies to, and you can see immediately it's put on the plates and bolts and so on, but they're not quite what we want. I could have had it remember a standard configuration, but this isn't a very standard scenario, so I'll set up all the options I need individually here. Let's adjust those bolt spacings. I think I could do with a stiffener in there as well. A bit thicker than that, that's better. Okay. I also need a base plate, so I'll go back to the connection vault, select a base plate for a tube, and this time that's put on a standard configuration, which looks perfectly good to me, so I'll stick with that. So now I'll copy that column, check the options here, rotate it around 30 degrees so that I have 2 legs per ring portion. And as I do that copy, you can see here that the joint at the top and the bottom goes with it. That's great. Let's have a think about doing a portion of our hopper now then. So I'm going to do some more construction lines. I'm going to go to a separate layer so I can see them clearly. And I'm going to do a couple of arcs again. So that's the arc for the bottom. Now the top arc, I'm going to move that up to make the right height of the hopper. I'll keep them offset to the main structure so I can see them more clearly, but I'll go back to the normal layer and create my plate between the 2 arcs now. So in run command, settings here, there you go, I've got my portion of folded plate out of 3 panels. That's smooth enough for me. And now I want to put a flange on top of that fold. So let's get it up in the right height. And now I'll move my coordinates. Let's move the plate round first so it's in the end of the beam. 10 degrees, that should do it. Yep. Now I'll put my flange on top of that. I'll get my coordinates in the right place to tell it where I want the flange to go. And put my plate on the middle of that segment and offset it. Yeah, that's nice. Need to bolt those 2 together, so I simply ask for some bolts between this plate and this beam, tell it where to put them, and check the parameters. So it's come up with 3 long, 150 gap. Looks perfectly good to me, so I'll stick with that. That's great. Okay, now I need to have 3 of those, so I can do a pattern of that plate. And if I, hang on, better put the coordinates back to 0 so I know where the centre of the vessel is. Now I'll do my pattern between those plates. 3 of those at 10-degree intervals. There you go. Now those flange plates aren't going to hold the hopper up unless I actually join them to it, so I use a fold, create a fold between this member and this member, and there you go, let's put the fold in the middle. And repeat that for the other 2. Fold there, and a fold for those. Smashing. So now I've got one complete panel of my hopper. Now on this 60-degree bit of ring I've got 2 panels, so better go for another pattern or a rotate copy. And I'll have 2 of those like so. Yep, that's good. So that's 1/6 of my ring. It's looking good. Now I can very quickly, with just a rectangular or a polar array, copy these members, and I'll have 6 lots, 60-degree intervals. Bingo, there you go. There's my whole hopper. So that's really easy, and already we're well along in our structure. Turn off the construction, I don't need that anymore. So I want to connect these top rings up, so I think I'll hide the hopper for a minute, turn off that layer so I can see what I'm doing a bit clearer. Let's have a go at connection, so I could do with end-to-end connection. That should do it. Okay, those bolts look like they're in a slightly strange position. Let's check the options. The settings seem sensible. Let's turn the plates on so I get the full picture again. Make sure I can see what's happening. Okay, the plates look alright. Let's edit that joint again and check the options once more. So if the plates are alright, it must be something to do with the bolt spacing. Perhaps we just change this offset. Ah, that's better, that's good. Right, so now I've got the joint configured how I want it. Let's hide those plates so that I can see the beams more clearly. And I can copy that joint that I've got there to all the other connections between the ring beams. One there. And it's putting the same joint in, or the same configuration in each of these 6 locations. Okay, that's done that. Turn the hopper back on. Fabulous. So the last thing we've got to do now is put some bracing on. So let's put my coordinates back in the right place between the legs there, so I can put some bracing between the 2 legs. I'll ask for the bracing macro to create some, and I want to go between those 2 legs like that. Before I set any options, what I'll do, I'll use this white box and I'll just adjust the top and bottom offset. So I need to move the top down a bit, maybe 300mm, and the bottom up a bit so it's clear of the base plates. Okay, let's have a look. Yep, that's good clearance there. Happy with that. So now I'll go back into the properties of the joint and set up all the beams how I want them. So first of all, I don't want a great big chunky channel. Let's go for a smaller angle. Get them oriented nicely. Oh, don't forget the gap between the beams. And I want 2 X's, that's good. Okay. I want a horizontal cross member, so I'll draw in a bit of angle directly from the end of that bit of bracing to this one. Choose the right size. It's on the heel. Don't forget to set the name. Okay, now that's gone between the bits of angle, and remember there's a 10mm offset, so I just need to move the front edge there, and I actually want to move it up equally between the two panels of bracing, so that should be in the middle now. And I'll create appropriate joints. So let's have a clear view of one corner. There you go. And I'll come into the connection vault once more under bracings. Let's go for a gasset plate. Simply choose the members. And there you go. It's not quite the shape I want, so let's have a look at the options. That's better. Happy with that. So I've got one I'm like. Now I can just do a copy again. I'll have another one of those joints between that column and that brace. These two and these two. Great. Now it's the ones in the middle. So we have options or versions of the joint for 1, 2 or 3 brace members. Let's choose each member. That looks reasonable. Same on the other side. Yep, looks the same. Happy with that. So once again, I don't need to do it all over and again. We can just make sure my coordinates are in the center and make a polar array or pattern to say I want to take these beams and I want 12 copies of them. There you go. A couple of seconds that's done, just turn off all those joint boxes. Lovely. That's basically our structure finished now. How easy was that? I'll tell you what I will do though, just for making the drawings nice, I'm going to put a bit of a grid on here. So I'm going to ask for a curved grid line from the base of this column to the base of this column, and it's got to go through the foot of this column. There you go. Yep, that looks good. And then I'll do a grid line across the diameter. So a single grid line. Just make sure I can see the legs clearly. Get the ones that are opposite. So it's the base of that leg. It's the base of that leg. And I'll have these numbered in letters instead of numbers. And rather than draw 6, I'll make a pattern of them. Okay, great. Now because they're all individual grid lines, I just need to quickly set the name for each grid line. So that one should be B, C, D, and E. Done. Okay, now we're ready to do some drawings. So to prepare for our drawings, I want to create some cameras. So first thing I'll do is think of what GA views I want, and these are, first one, foundation view. That'll show us where all the base plates go, and I'll set up some parameters for that. Choose the right style of drawing. It's a stanchion layout. I'll have another camera. I just want to do the base of 1 foot, so this will be an enlarged one, just of the base plate. Don't need to show the whole structure, just want to limit that to a certain area. I think 400, yep, that looks like it's going to cover the base plate, and that's a detail of a base plate. While I'm here, I can set one up for an overall plan view. That can be the entire structure. I'll just have a nice simple overall view. I think I'll do an elevation of the whole thing. Front view. And while I'm here, let's do a section through the centre line, shall we? So I'll choose a section view style this time. Now, I also want to do a 3D view, so let's orientate myself for a nice 3D view, and then I'll ask the coordinates to match the screen and say I want a view to match this. Just call it ISO, that'll do, so I'll recognise which one's which. Okay, now this front view, actually would rather have it looking flat onto the bracing rather than one leg, so I'm just going to rotate that. 15 degrees should do it between the legs. There you go. That'll be flat onto the bracing, so one piece of bracing will be presented square on in the view. So having set that lot up, I now need to number the components in the structure. So the system here automatically calculates which components match and how many of each part there are. And now I'll come in here and click on this button to say, give me all the drawings I've set up. So now while it does that, you can see on the command line flashing by there, it's creating all the GA drawings that I've asked for. There's the cameras I've set up, 5 or 6 different views. And it's going to create all the necessary assembly drawings and all the necessary individual part drawings for me. And you can see there that it's creating the view in memory, then it's testing the scale and the paper size, trying a range of different scales on each paper size till it finds what it considers the best match. Each drawing will be fully dimensioned, ready for manufacture. Okay, let's finish those. So let's take a quick look at what we've got. Let's have a look at the GAs first. There's a preview of our foundation drawing. So you can see there I've got all the foundation plates shown, the base plates and the nice grid lines and some basic dimensions, and there's the enlarged detail of one typical base plate. Next drawing, there's our plan view and our front view. Section view looks a bit messy though, so maybe I'll just go into the drawing and have a closer look at that. Don't really want all these labels, let's delete these, just simply select them. And delete them, and maybe I'll turn off the hidden detail as well because I think it'll be cleaner without that. Now depending on which style you choose, it wouldn't have created hidden detail or wouldn't have created labels in the first place, but there's many different styles and you can manipulate each one to suit whatever you want, as simple as that. So I'll just close that. Let's have a look at the rest of our drawings. So there's one more GA to look at. Yep, that's our nice isometric views. That's great. We didn't really want that on a separate drawing though. I think there's, yep, plenty of space left on the foundation drawing. So how about we move that isometric view to the foundation drawing there. Just drag it up and the drawing 102 is deleted and that isometric view is now perfectly placed on the blank space on the foundation drawing. Lovely. So going on to the assemblies, this is our column assembly and that looks okay. And there's a curved beam for the beam ring. Let's just touch that one up a bit. Some of these dimensions are a bit untidy, so it's not a problem. They're all the ones you need on there. In fact, I'll probably live without that one altogether. And you can just grab the others and move them around in or out using the grips and place them where you think is tidier. As you'll see, most drawings they get pretty good straight away, but some of the curved ones you just want to touch up or shuffle a couple of dimensions around. It's very quick and easy to do. Let's put that there. And what I've got going on this end. Move that in. Over to about there. That's the end plate, don't want that one. Leave that all together. And that one's the stiffener. This one can move in. And that one better move up a little bit as well, I think. There you go. Great, that should do it. So that's much tidier, and he took a few moments. All the rest of the dimensions he needed there. Let's look at the rest of the drawings. These are mostly the plates. There's the gusset plates, the bracketry and stiffeners. Oh, this is an interesting one. Let's open that up. So this is our folded hopper section. Now these holes at the top, because they're on a curve, really, you wouldn't really dimension them like they've done here. So let's just delete these chains of dimensions, and we can put our own chains in instead. So it's very easy to add your own dimensions. You just, much like any other CAD system, and it gives you the true measurement from the model, regardless of scale. You get the real size. All scaling taken into account. Let's create a chain across here. That's fine. Okay, so that's just gone a little bit outside the border, so it's not a big deal. Just grab that frame and move that view down just a little bit. That's nice, that's fine. Okay, so that's tidied up that drawing, and you can see it's got the full development of the hopper plate there. Any more drawings to look at? Which one were we on? Oh, that's the one we just did. Okay, these all look fine. Okay, time to do some lists now to go with that, some bills of materials. Let's do a straightforward material list. Okay, there's our list. Just ask a few clicks and it creates a very professional looking list, nicely formatted with all the information, and you can also export that to common formats like PDF or rich text, or if you want to go just a plain unformatted text such as is used by many other systems, you can just export it. But you don't have to have this information, the beam sizes and so on. You can go for lots of different types of list. If you have a look through, you can see we've got all sorts. We've got bulk summary lists that list quantities if you want to buy and buy the bucket load, or you can have, perhaps we'll generate this one, bolts according to the assembly they're in. There you go. So each assembly is listed and the bolts that go with it. So when you're constructing on site, you can take the right fasteners with you. Okay. You can also create all the NC files for automated machining and DXF files to go into the plate profilers. Blink and you miss it, they're so quick. Let's have another look at those in the document manager. Everything's controlled by the document manager. So here we go, there's our NC files. You can see the coding there, all to the STV standard. Different types of beam, all the bolt positions, the contours, even the folded plate has the contour defined accurately in there. And then these are the DXF files you can feed straight to plate profilers. One-to-one simple drawings, even the folded plate again, one-to-one drawing with the etched fold lines shown there as well. So that's all the manufacturing documentation you could need. Okay, let's have a look at some examples we've got from customers in the UK. Just load a couple up. Okay, now here's a sample with some square hoppers, but there are quite a few, quite large on this structure here. So you can see he's got the full supporting structure, made the hoppers out of the panels of plate. It's got the access platform underneath with the railings and everything included. This was actually this user's first project in advanced steel. Here's another nice project, industrial platform. Some good hoppers there, various shapes and sizes. In fact, what I can do is come here. Yep, going on that layer state, I can show you just the hoppers on their own. So you can see there that we've got square hoppers made out of flat panels, we've got full cones, and we've got the circle to square shapes as well with the offsets. So lots of variety there, showing the extent of the plate work for that structure. A good range of tools used there. And then another one, this is a little bit different, it's more of a filter box or hopper. It's got various inserts and structural members around the outside to hold it together. Mostly flat panels though this time. So advanced steel is ideal for creating any kind of plate work you need, folded plates, hoppers and so on, and very easy to create the necessary supporting structure. So thanks for watching that. I hope you found it interesting. If you'd like any further information, please don't hesitate to contact Graitec with these details. Thank you very much for watching.